Okay, let's take a look at the wheel and axle notes that you should have written down and sent to me. All right, wheel and axle. A wheel and axle is simply two wheels of different sizes that rotate together. All right. So you have a axle. The axle is the center part of the wheel, and then you have the wheel out here. So think of the idea of like a steering wheel. Well, that doesn't show very good, does it? Kind of too light. So let's try that again. There we go, and there. All right. So now we got like these the spokes that come off right here for like a steering wheel or a bicycle wheel. So you got the axle that's in the center, and then you got the wheel around the outside, and they're going to rotate together, obviously. All right. Examples of things that are like this would be like a faucet handle. Right. When you grab a hold of that faucet handle, actually in the inside, there's just a little bitty axle that's in the center that turns the water on and on, or turns the water on and on, turns the water on and off. Right. But then you got the handle part that allows it so that you can you get enough mechanical advantage in order to turn that. If you ever have a faucet handle torn apart, awesome piece I want you to try someday is try and take that little bitty part that's going to stick up and try and turn it with your hand. And you'll find it's really hard to do. Sometimes it's almost impossible to get it to turn on. And what the handle does is it makes it bigger, so you get more mechanical advantage in order to do this. Right? A door handle is another example. Right? The door handle makes it so we got something big to grab hold of, because again, in the center there's a little bitty axle that does the turning, that does the work. A screwdriver is another one. Right? You got the screwdriver part in the center, the handle around the outside. And what you need to think about in regards to wheel and axle is really what it is. It's just a lever. So you got this lever that's attached in the center in here, and then it comes out here, and this is where you're going to grab a hold of. Okay. And what it turns out to be is a second-class lever. The way in which we know that is here's the fulcrum, that's on this side. Here's the effort that you put into. The resistance is right along the edge of that thing, along the axle part. So resistance is in the middle. So if you remember the free answer that I gave you, resistance is the second one in FRE, so it's a second-class lever. Second-class levers usually multiply force. So that's what that steering wheel is going to do, is it's going to multiply the force. In order to figure out that, figure out mechanical advantage, you take the radius of the wheel, so that's the distance from the center out, and you divide that by the radius of the axle. So that means you go from here to there, just that little bitty radius right there. And you divide those two, and that'll give you the mechanical advantage, which is usually a lot when you're talking like a big old steering wheel on something. Right? I know for myself, when I've used screwdrivers, if I have a screw that's stuck, I'll take the screwdriver, which looks like here's the screwdriver, and then you got the handle up here. What I will do is I'll actually take a pliers and attach a pliers to it that comes out this way, so now I can grab a hold of that and twist it, and it gives me even more leverage on that screwdriver. Bad part is usually one of two things is going to happen. I'm either going to get the screw to come out, or I break off the tip of the screwdriver, which is more common. What ends up happening, it breaks the tip of the screwdriver off. So another example of mechanical advantage is a thing called gear ratio. If any of you ever decide to work on cars, and you want to like make a drag racing car, or you want to make a four-wheel drive big monster truck, one of the things you'll have to think about is a gear ratio, which is in the rear axle. And what you look at on that is you're looking at the ratio of this to that. And it gives you how much torque, how much power you're going to have, how fast the vehicle is going to go. And it all depends upon that mechanical advantage between those two. If you're going to do a monster truck, you want lots of mechanical advantage so that you can make it roll over the top of things. If you want to make a drag racing car or a NASCAR or an Indy car, then you're going to want that ratio to be a lot smaller so it'll go faster. Right? But you're going to lose a lot of power that way. So, all right, well, that is the wheel and axle notes. So we'll talk to you next time. See ya.